In this session, let us discuss on the interference of light. This experiment was conducted by Thomas Young. He was a British physicist. This experiment created a hallmark in the history or in the study of light, since it provides a direct experimental support in favor of wave nature of light. Let us understand what is an experiment, experimental setup. There is one opaque screen with a slit in it, single slit. Then one more opaque screen with a two slit in it, closely associated. Here, light is allowed to pass through this slit, and the light that emerges, it can pass through this slit as well as this slit, and appear as shown in the figure. What is this diagrammatic representation? When the light passes through the slit, the size of slit, what should be the size of slit or hole? Extremely small hole. The size is of the order of wavelength of light. That small is the slit or opening. In that small opening, if the light passes through it, what happens? It is spread out as spherical waves. Even though light has planar wave fronts before it passes through, then those wave fronts bend and spread as spherical waves while passed out. That is the reason to have this kind of hole. And same thing happens here through these two slits as well. The light thus emerges. It is passing through this slit as well as this slit and emerges as spherical waves like this. Passes through space. What is the reason for these two slits or single slit? If you use any source of light, maybe sunlight or any source of light, if it is monochromatic, it is well and good. Single source. When the light coming from this same light will come out as two different sources of light. Will coming out from here. These two lights are said to be coherent sources of light. Light of same coherence, coherent sources. What is meant by coherence? That is light having same phase or constant phase difference with time. Constant phase difference with time. It means the light source from this have same fundamental properties like wavelength, frequency and the speed as well. Those waves are said to be in phase or constant phase difference. They are called as coherent source of light. And if you keep a screen like this at certain distance from here, we can observe a series of fringes on the screen. Series of fringes on the screen. Fringe means band of light. These series of fringes are bright fringes, dark fringe, bright fringe, dark fringe. They are in the alternate fashion. These series of fringes are in alternate fashion of same size, same width. Fringe width remains same. Bright, dark, in always alternate fashion on the screen at different points. The distance of screen remains same at different points of weighted fringes like this. This observation or the fringes like this is a direct evidence for the wave nature of light. If the light is particles, the corpuscles are small particles, this wouldn't get, or we wouldn't expect this kind of fringes on the screen. If the light is of corpuscular particles, we wouldn't expect this kind of fringes on the screen. It may be a bright background, completely a brightness on the screen. This is that the light, these are waves. And one more, why are you using coherent sources of light? If we use the lights which are not coherent, that is two different sources of light, here one source, another source, and the light emerges like this only, well, these two lights would not have coherence. The reason, they are not in the same phase. They produce us what is that wave, that is the light of different frequency or wavelength. If the light sources or light waves having different frequency or wavelength, they cannot be in the same phase. They cannot be in the what is that constant phase difference. They are not coherent sources. If these two sources are like it, we won't get a fringes on the screen like this, but interference like this. Here, the fringes on the screen, it is due to interference of light waves. That is the one we need to understand. What is meant by interference of light? This fringes is due to interference of light. Interference means when the waves on the screen, the two waves cross with each other at different points. At this point, two waves cross each other at a point here. And at this point, two more waves cross each other at this point. That is a point of interference or point of intersection. So, different waves, what is that? Cross each other. When they cross each other, they fuse each other at a point. And after fusion, after combining, what is the resultant? Resultant is a change in the amplitude of the wave. Change in the amplitude of the wave. And the fundamental wave properties, what I am talking about, the fundamental wave properties, wavelength frequency before interference, wavelength frequency after interference, rays cross each other and pass in their own direction. Before interference and after, that is after that interference, the fundamental properties remain same. Their amplitudes, wavelength frequency remains same only at the point of intersection. I'm talking about the point of interference. Here I'm talking about two waves passing. This is the direction of the wave passing. This is the direction of the wave passing. And while crossing each other, they meet at this point. This is the point of interference. At this point of interference, there is a change in amplitude of the wave. If the amplitude increase, you get a bright. If the amplitude decrease, you get a dark bridge. Since the amplitude of the wave is related to intensity of the light. I told you, you know that intensity of the light is directly proportional to square of the amplitude. That is the reason when the amplitude increase, the resultant amplitude at the point of interference increase, you get a bright. Any decrease or zero becomes dark like this. Alternate. That is the reason for this interference. This interference is taking place in case of wave nature of the light. And once again, I recall the waves. That is a definition of wave in brief. As you know, these are the spherical wavefronts spread in space. Spherical wavefronts spread in space. And they travel in all directions. That is, traveling in one direction, that is in linear direction. How do we represent it? That is spherical wave. I say this is spherical wave like this, spherical line. I can call this as a crest, and there is no line at the trough. Crest, trough. In one direction, there is in single direction like this. How do you represent that wave traveling in this space? Crest, trough, crest, trough, crest, trough, like this. And this wave is due to displacement of particle from the equilibrium. That one time it displaces direction and it like this, other time other direction, like this wave nature. This wave character, of course, this wave carries energy generated by the space, that is by the particles, of course, in the space. It is defined by this equation, sinusoidal equation. A into sine of this function. The A represents maximum amplitude, that is the distance between this point and this point. And distance between this point and this point is also amplitude, but less than this. Amplitude variation during oscillation, disturbance. Here in this direction, amplitude variation maximum and decreases, maximum decreases like this. There is a wave equation says that. Y says that it is a variable like this with the time along x. So sine of this. And there are two terms in the equation. There is a minus is that. Minus indicates that this wave is propagates in x direction. It is positive. It is the positive direction of x. If this is plus, the wave will propagate in the opposite direction, negative direction. Minus for this propagation like this. There are two terms. That is kx. K equals 2 pi by lambda. It is called spatial term. What is K stands for? K is 2 pi by lambda. This is the wave number. The term represents the wave number. Says how many waves are packed in 1 unit of length. So it represents the packing of waves. Close packing or loose packing. That is the wave number. 2 pi by lambda. Why it is called a spatial term? These waves have some geometrical shape. They are what is that? They spread in the space like this. Shape called spatial term. And it carries x along the x. It is that wave is carrying along the x. And next term is omega t. Omega means angular velocity. It is not a linear velocity. Changes the velocity like this. Angle change in radians like this. Angular velocity. This angular velocity equals 2 pi f. What is f? Frequency of the wave. How many waves like this? One wave. Wave like this are generated in 1 second along the line by traveling. F. And f equals 1 by t. That is definition. Time period. Time taken to travel the wave from one point to other point. One wave. Omega t is a time dependent, time related. This time, how does it changes? That is a temporal term. Temporal term is time dependent. This is called as temporal term. This is called as a spatial term. And the summation, what is that? The plus or minus gives the number without unit, a numerical value without unit. That numerical value is always in pi, that is pi by 2, pi by 3, pi by 5, 3 pi by 2, any pi in terms of pi only. That is a numerical value. That is a pure number without unit. And the sign of that gives what is again numerical value changing from minus 1 to plus 1 via 0. That is minus 1 to plus 1 via 0. Minus 2 plus via 0. That is the sign of all the values over time. It is ranging from minus 1 to plus 1, 0 through 0. Nice. Depending on that, we get amplitude. That is, the amplitude variation is that with time. So, it's a constant. So, it may, what is that? Decrease the rate, different values like this, different values like this. Accordingly, what is that? Sign gives plus or minus value. That is why it is a representation of sinusoidal wave in mathematical definition. Any sinusoidal wave, it is given by this equation. Now there are two equations. There are two waves, and two waves are coherent waves. That is, same wavelength, same frequency, same amplitude as well as. And write the wave equation for this wave y1 as this. And wave equation for this wave as y equals a sine of this. The difference between this is pi. It says phase difference. It may be 0 or constant phase value. Pi difference. So if this is a constant value or 0, these two waves are coherent waves. And here, while traveling in the space, they touch here between them, that is cross here at this point. That point, this point, they touch each other, is a point of interference. This is a point of interference. Only at this point we can see a change, and no other changes away from, that is after this point and before this point. The fundamental properties remain same. Same amplitude, same wavelength, same frequency at this point. It is only amplitude change. Let us calculate. How do we calculate the resultant of the wave at this point? Since wave is a vector and vector, two mathematical equation functions, vector quantities. When you add up two vectors, that is then this vector plus this vector, it will follow the principle of superposition, addition. Principle of superposition is always for the addition of two vector quantities. gives a resultant vector. This is a resultant vector. Let us add these two, this plus this. This is sine, of course there is a common factor, sine plus sine. So add these two equations, see what you get. Apply this formula and add up. Sin A plus sin B, where A is this here, B is this. Now here and here, this A is numeric of course here. Use this formula and find out, we get an equation like this. One is, that is sum into product, okay. We get cos and sine. And compare this equation to sinusoid, because whether it is superimposed, that is superimposed, that is combined or away, that is always follow the wave equation. Wave equation is sinusoidal wave equation. This is sine wave and remaining should be amplitude. This amplitude. So this resultant amplitude of the two waves due to interference is this. Let us calculate the resultant amplitude for a standard phase differences. If that is phi equals phase difference. Phi equals the standard phase difference is 0, 2 pi, 4 pi, 6 pi, 8 pi. What is that? Even multiple of pi. For these standard values of pi or phase difference, what is the value of this? This value equals 2a, because cos of, that is pi by 2, that is this by 2, this by 2, this by 2 is always 1. So cos pi by, that is pi by 2 is always 1, it becomes 2a. What happens when when two waves interfere at this point? The amplitudes are multiplied, that is twice the amplitude. Amplitude of this plus amplitude of this, 2a. It is maximum amplitude it is produced. Therefore, if the interference is constructive, it becomes a bright spot, that is a bright interference, that is bright fringe. The bright fringe on the screen, it is due to the phase difference between these two. It may be this or this, 2a amplitude. That is the pictorial representation of resultant amplitude. Here the waves are traveling in different direction. This is in this direction, this is in direction. But here I am taking the waves, I am taking only half a crest only, there is half wave. The waves are traveling only in one line, but in the opposite direction, this same line. That is one wave traveling in this direction, other wave. Both are what is a crest or peaks. When they meet each other at this point, they become an amplitude like this, double. Same wavelength, same height. When they meet, we get a resultant, add up, combine these two. At this point of intersection, they combine only variation of amplitude. And after that, what is that? Then what is that? They travel or pass in their own direction. This is a direction. Their own direction along this. This is a direction, this is a direction. After this, what is that? Retain the original wave character. Same wave number. Same wavelength, same frequency or same amplitude. Because of wave 1, wave 2. After passing over in this direction, these two are separated. It is their own direction. Only at the point of intersection or the interference, amplitude changes. If that is the case, it becomes 2a, resultant amplitude. That is a mathematical way of calculation, this is a pictorial way of calculation. If at this point of intersection, if the phase difference is these values, pi, add multiples of pi 3 by 5, phase difference. If the phase difference of these values in this case that is pi by 2 or anything like that. 3 pi by 2, all these values now become 0. Cos of that values becomes 0 always. If it is 0, this is 0. The amplitude becomes 0 and the wave becomes 0. That is why minimum amplitude, that is a 0 amplitude. If the phase difference between them is these standard values. Now the pictorial representation is the same waves, but here crest, trough are traveling in this direction. When they meet each other, what happens? Same wavelength and same height get cancelled in the opposite direction. This plus this becomes A equals 0. Resultant wave is 0. Only line, no wave. And after that they pass in their own direction. It is in this direction, it makes the same fundamental properties, carrying same amplitude, same wave number. If the waves of phase difference, any other value like this, we get a resultant amplitude that we can calculate in the same equation, that is, substitute that phase difference, calculate this value, it is different. What is it? Maybe bigger, either plus or minus some value, a value. That is in general. Here, one thing I need to stress upon, at when the two waves interfere with each other, at the point of intersection we see only a change. What change? Amplitude change. And then onwards, that is after that or before that, the fundamental properties remain same. No change before and after. Only at the point of interference we see a change, that to amplitude. This is very important in this case. In this case, here countless number of signals are traveling in this space. That is passing through the space. Countless number of signals, maybe audio signals or video signals, sending from one point and receiving at the other band. Here countless number of signals are passing through the space. While passing through, they cross each other many times. These waves, that is signals, they cross each other number of times, but only at the time, that is point of intersection, there is a change, and after that and before that, the fundamental property of wave number, that is wavelength, frequency and speed remain same. That is why, in case that is, although there is an interference in the space countless number of times, interference is there because of waves are crossing with each other many times, but what the signal we receive at the end, it is same, that is original, what they sent from the other end, same signal we receive, same signal, that is the signals of same wavelength, same frequency, that is the original signal. That is why we see what is that same kind of, what is that audio or video, what they sent here and what we see here. There is no disturbance here, even though the waves are interfering with each other many times in the space. That practically very important to understand what is the meaning of interference. Interference is taking place only at one point of the waves where they meet, and there is no change and before and after they cross over. That is the one meaning. What is that here? Here fixed only at the point, and before this and before this you are not seeing. That is only at the point fixed. It is a fixed point, fixed point. This is fixed and these points alternate. Fringes are obtained. This we understood. It is meaning of interference. And one more in this geometry is here, and the same geometry are written as like this: single slit, double slit screen, on the screen on which these fringes are obtained. Here, that is slit 1, slit 2 holes, and the distance between them is d, of course very small, extremely small, d, and the light passing from here I am showing in the form of ray, that is in the form, that is wave friends, of course, wave friends, that is in the form of straight line, a ray of light here and a ray of light from this slit, and touch at this point on the screen. Let us say P is the point, and at this point we may get either bright fringe or dark fringe. It depends on the bright fringe, either bright fringe or dark fringe. At this point, bright or bright point, it depends on this length difference. Look at this length is, what is that? That is the length of the ray. The light passes from this point to this point and passes from this point to this point. This length is the path difference. Path of the ray are always different. That is, one is higher, other is lower. Teaching that. And this is the line I am drawing, straight line. This is called as the path difference. So I can write this path difference as b minus a. Let us call this distance as a, this distance as b minus a delta z as path difference. So this path difference is related to, what is that? On which point we get a bright point, at which point we get a dark point. So that we need to understand. So we have one mathematical equation which can explain with this path difference, where you get different positions. That is, from this point onwards, what is that? We get fringes in alternate fashions. Here also from this point downward, fringes in alternate fashions. Here you get always a bright, because the light from here, again the light from the same line meet here without any path difference. They always produce a constructive interference. This is a constructive interference. So this is what I am talking about, the constructive interference. This is the destructive interference. Here constructive interference, destructive interference. Constructive interference. And let us, using this diagram, we can derive that equation. We can derive it out, mathematical equation. Let us derive that equation using the same geometry. So in this we have, let us call this point as B, this is O, this is A, and if it is D, the distance is D, then this distance is D by 2, this distance is D by 2, the center point. And let us call this, the distance between this center point and P is X, where we get the fringe. And the distance between these double slit and the screen is D, capital D, that is always the numerical values. In this geometry, let us see that there are two triangles. That is, this is one triangle, the right angle triangle, and one more triangle with this line. This is a right angle triangle, I say. For these triangles, let us apply what is Pythagoras theorem. That is Pythagoras theorem. In this right angle triangle, that is triangle, hypotenuse square is equal to sum of the other two sides. This square of this side plus square of this side. Square of this side is, the side is d square. Square of this side, what is the distance of this side? This side, here to here x. Then from here to here, x minus d by 2. X minus d by 2, whole square, square of this distance. Similarly, in the triangle like this, right angle triangle, that is hypotenuse square equals square of this side, square of this side. Square of this is d square, square of this side is here x plus d square, x plus d by 2, x plus d 2 whole square, square of the sides. These two equations you get. Now we can subtract 1 from 1, 2 from 1. 2 minus 1. Left hand side, right hand side. Left hand side a square minus b square. This minus this. And expand. Let us expand this as b square minus a square, that is b minus a plus b plus c equals and apply a plus b whole square, expand it. Right as it is, we get this. A plus b whole square for this. Minus of bracket, write the same. Apply a minus b whole square, we get this. Minus of this. Remove bracket, minus applies to all. And see that there is a cancellation. And the plus, minus, plus, minus, plus, minus. This minus becomes plus. So overlay plus, plus 4x d by 2. Here 4 by 2 becomes 2x d. Here b minus a into b plus a equals 4x d by 2. And we can write b minus a equals, rewrite the equation as b minus a equals 2x d divided by b plus a. Take it to right hand side. Now observe this b plus a. What is the b plus a? The distance of this ray, and also observe the distance between this and this d depression. When you look at the differences in values, in reality, the differences between this length and this length, very small, negligibly small, very extremely small value. If that is the case, we can approximate them as equal. In this case, in reality. So we can make some approximation. So this length equals this length equals this length. That is the case. B equals D, A equals D, becomes 2D. Denominator becomes 2D. Simplify 2 to get cancels, x by D by D. That is B minus A. It is called as path difference. We get xd by d. So the path difference, I'll tell you in this class. How do we get bright? What is the condition for formation is bright fringe and dark fringe using path difference. But this path difference is given by the mathematical function of, that is xd by d. What is x? Distance of the point from O, fringe from the O. And what is the slit separation distance? And capital D is the distance between the double slit and the slit. So this is the equation. This equation can explain conditions for constructive interference and destructive inference. Constructive for bright fringe, destruction for dark fringe. The next class we shall understand that. Thank you very much.